Hello everyone, we are the Flyboys team from NC State and we're going to be presenting our IAM3D design for the 2020 eFest Digital. Our team is made up of 5 members, Bennett, Hunter, Adam, Shreyas, and Eli, ranging from freshmen to seniors in both mechanical and aerospace engineering. To start, I will go over some of the critical components used in our design. The main component to any quad is our flight controller, followed by 4 ESCs, each connected to a motor. Other important components are the receiver, video transmitter, camera, and battery. Not shown are the radio transmitter and VR goggles.
Designing the payload pickup mechanism was an important part of the project, as it was one of the main factors that would affect scoring in the competition. In order to pick up each payload, we decided to use an electromagnet on the bottom of the quadcopter that could be powered on and off from our controller. The magnet is secured by a holder that is built into the top of the frame. In order to better see the payload as the quadcopter neared a pickup, we also added a secondary camera underneath the quadcopter that allowed us to see where the magnet is in relation to the payload. The controller allows us to toggle between the main and secondary cameras. In order to do both of these things, we added a real pit power switch to act as a transistor that would switch the electromagnet on and off from the transmitter, and a BIX multicam switcher to switch between the main camera and the mini camera below the base of the quadcopter.
Several aspects of the frame were designed to make assembly easy, both when initially putting things together and for quick repairs. The first component that was designed to come apart easily was the top from the bottom of the frame. This allows you to access the flight controller and basically all of the other components without the top being in the way. The top snaps into the bottom of the frame with a flexure clip that makes it easy to go in but difficult to release. The second design aspect that is important for assembly are the 4 removable arms that clip in and out of the base of the frame. This allows for an easy replacement if necessary, as the arms are the most vulnerable in the event of a crash, and it operates in a similar way to the removable top. The third design aspect I want to cover are the housing slots that the motors are contained in. These constrain the motors in all but one direction, and though there are holes for all 4 screws, only one is needed to effectively secure the motor. This means less time to swap out the motor if need be, as you only have to undo one screw and slide it out. In addition to this, the 3 wires necessary to power the ESC all have connectors so that the motor ESC pair can be swapped out in a matter of seconds if need be. The final design for assembly and manufacturing aspect I will cover are the slots for both the receiver and transmitter antennas. These slots keep them oriented correctly without needing to use extra fasteners to keep them in place.
Throughout the design process, our group used finite element analysis, or FEA, to study the structural properties of our drone. However, FEA using 3D printed parts is very challenging because additively manufactured parts are highly anisotropic. Additionally, specific printer settings can have a huge effect on the resulting part's strength. As a result, our FEA simulations were used mainly as a basis for comparing various designs and as a guideline rather than fact. The PLA parameters we used for the FEA simulation were taken from My3D Matter, who conducted various empirical tests on different filaments and different infill configurations. The boundary condition setups and the FEA results are shown for each part. Both parts were meshed using a 1mm resolution, which finally resolved the part. The FEA results show that the maximum von Mises stress on the parts is well below the yield strength of PLA plastic. However, again, we must emphasize that this FEA is to be used as guideline only due to the difficulties of conducting FEA on 3D printed parts. Our group's design is especially optimized for additive manufacturing. While many different optimizations were made, I will discuss support material here. By using 3 strategies, modularizing or splitting our parts up into separate parts, inclined overhangs rather than sharp overhangs, and bridging, we were able to avoid the use of support material throughout the build, which saved on print time and print material. Keeping these 3 strategies in mind, we designed an innovative latch that connects the arms to the body. This latch is 100% 3D printed and requires no other fasteners to work. It also doesn't use any support material, just like the rest of the build.
In the first iteration, the frame was printed as entirely one piece that failed due to overhangs that required large amounts of support material when printing, and any breaks would require a full reprint. The second iteration featured a modular design with the removable arms and a frame that separated into an upper and lower piece connected using a simple set of hexagonal press-fit pins and circular holes that did not provide a secure fit. The presented iteration featured an advanced clip designed to secure the upper and lower frame together utilizing a T-shape to constrain motion in all directions. As a result of the FEA shown earlier in the presentation, we learned that the lower frame would be the point of failure in our design. To confirm this, we applied force to the frame in a manner that caused it to bend up to 65 degrees, which was much more than the predicted deflection from the FEA. Finally, we performed full flight tests to gauge the performance of the final product. During the flight tests, it was found that the quadcopter was remarkably capable of agile and acrobatic maneuvers, and it was able to withstand the high accelerations that come from thrust at full throttle, and the electromagnet was able to pick up and release the payload easily.
Although we never got to compete with this project in person, the designing and building process taught us a ton about both multi-copter design and 3D printing that most of us had never encountered before, and was a very rewarding experience to every member of the NC State design team.